Sivagiri THEERTHADANAM പുരോഗമിച്ചുകൊണ്ടിരിക്കുന്ന ഈ വേളയിൽ നമുക്ക് ഇനി അടുത്ത പ്രഭാഷണത്തിലേക്ക് കടക്കാം.
Today I am going to talk about Earth. Everyone knows that the Earth is somewhat about 456 to 457 crore years old. So during this long journey, it has undergone so many geological processes and geological events. So learning and understanding is a must for everyone, not only to geologists. Because if I ask a question, if someone get a chance to go to moon or Mars, any other heavenly bodies, everyone will be happy. Everyone will be raising their hand. But things are different. Once you reach moon or Mars or any other body, heavenly body, on the second day, you will be wishing to come back. Why? It is not because of homesickness, but rather those areas looks very monotonous. Everywhere you go, the area, the terrain looks very similar. But think about the earth. You have different climate. You have different beautiful places. You will be welcomed by different people. You can see different dresses. And last, you will have different food to eat. So that is the biggest advantage of earth. You will never get bored if you go for a tour around the globe. You will be happy. You will be seeing different things. So it is mandatory to understand about the earth and its journey through space and time. So there are, as you know, every scientific processes will be governed by several theories and hypotheses. The same is with the origin of the earth. There were so many hypotheses. There is no one theory for the origin of earth. You might have heard about the origin of universe, but that is explained by a theory, whereas the earth, origin of earth or the entire solar system is explained by a hypothesis. So all the hypotheses were clubbed. If you club together, you can divide into two. So first is that a group is called catastrophic hypothesis. The other is called evolutionary hypothesis. The most important hypothesis in the evolutionary group is a catastrophic group is by a passing star hypothesis, in which the hypothesis mentioned that there was sun and there was another star passing by star which collided the sun and took a good amount of sun's material, dropped at different places, and those become different planets. But in the evolutionary group, the most important one was explained by nebular hypothesis proposed by Immanuel Kant and Laplace. So it is called as Laplace nebular hypothesis. So in that one, it says that in the primitive, there are clusters in the universe. There were clusters of dust, gas and rock particles called nebula. These nebula are created to form solar system. There are so many such solar system in the universe. So if you say that the innermost part get concentrated and because of the gravity it collapsed and formed the sun, and the rest formed as planets. And you can see that the planets which is close to the sun are very denser, whereas the planets which are further from the sun are less denser. That's why Mercury, Venus, Earth and Mars are called terrestrial planets, because it is a rocky planet, whereas the further other planets like Jupiter, Saturn, Uranus and Neptune were called jovial planet or gaseous planets. So it is like an example. I can say, if you fill a sack with different materials and if you make it a jerk, the heavier things goes inside and the lighter comes on the top. The same is the thing. The denser materials formed the terrestrial planets, whereas the lighter gaseous things formed as gaseous planets. That's why it is bigger in size, because it is gaseous. So I have told that the origin of solar system was explained by nebular hypothesis. But in the coming years, this hypothesis is going to be converted into a theory, because in the night sky, those who are curious to watch night sky, you might have seen 3 stars aligned in a line, and we call it as hunting stars. Okay, so south of that hunting stars, there is a new nebula forming with a star originating in the middle of the nebula, which is called Orion Nebula. So we are getting a clear-cut evidence how a nebula is converting into a star as well as different planets. So this is based on this observation. This nebular hypothesis will be shortly called as nebular theory. And during this saying about the history of Earth, when it formed, I have told the nebula have accreted or collapsed together to form planets. So what happens when it collapses or accretes? You can see that gas, dust and rock particles will collide each other and form bigger planets. So while forming such process, the rocks will get melted. So you can imagine about the melted earth once upon a time. That earth was called Gaia, G-A-I-A. And there is a big difference between the present earth and the earlier Gaia, which I will be mentioning after a few minutes. So this earth was, the Gaia, the younger earths, was much bigger in size. Again, I have to use the term or example, fill with the sack of material, jerk it. So when it initially fill it, the sack will be full. So the earth was much bigger. So what happened is that the surface temperature of the earth was something else about 2000 to 3000 degrees Celsius. Can you imagine about such a temperature? Because of collision of different heavenly bodies. So during that time, only 2 processes were operating on Earth, 2 geological processes. One is volcanism. Volcanism means you cannot imagine about this volcanism. I will quote you an example about the volcanism which happened in 1991 in Indonesia later on. But now everywhere on the earth it was volcanism. Lava, magma, gaseous material, water vapor were ejected continuously, and the molten rock flows over the surface of the earth. And the second geological process which operates on earth is meteoritic impacts. You know meteorites? Meteorites are heavenly bodies which haphazardly travel across the solar system or planets, but now constrained to an orbit between Mars and Jupiter called the main asteroid belt. So meteorite and asteroid, we can use it synonymously. When it comes to Earth, we call it as meteorite, otherwise it is called asteroid. So it was continuously bombarding the Earth. So the surface of the Earth was totally dotted with the depressions because of the impact. And the impact, what happens, made the biggest problem is that not only it creates a depression, but it partially melts the rock where it hits the surface. So the earth was totally a molten condition. So that was the initial Gaia. Now we can say about the different parts of earth. You know, earth is divided into 4 important spheres: atmosphere, hydrosphere, lithosphere and biosphere. So I'm not going to mention about biosphere because that is the one which came later, biosphere. But about atmosphere. So when the earth was formed, there was an atmosphere which was very thin. But I have mentioned to you that surface temperature of the earth is something else about 2000 to 3000 degrees Celsius. Can you imagine any gas sustaining in such a temperature? No. So what happened is that all the gases present in the atmosphere diffused to the outer space. So we were not having an atmosphere for quite some time. So then we got a secondary atmosphere which is mainly formed by the degassing from volcanism. So volcano, you cannot imagine how much quantity of gaseous materials are ejected during a volcanism. I have told you I will be quoting an example of Pinatubo, where I will be mentioning about only one gas, sulfur dioxide. But our atmosphere is enriched in nitrogen. So if I am saying about sulfur dioxide, you can imagine about the quantity of nitrogen, how much amount of gas is emitted by volcanism. So that is the scenario. These are the problem with the atmosphere. It cannot survive. It diffused and a new atmosphere formed by volcanism. So what the atmosphere we see today is not the secondary atmosphere. It is a tertiary atmosphere, or I can say that it is the fourth generation of atmosphere, which I will be mentioning about when I will talk about oxygen. Because when the primitive atmosphere, the earth was devoid of oxygen, free oxygen. Oxygen was there, but not free oxygen. So that is the case of atmosphere. And when we talk about hydrosphere, hydrosphere means related with water. In such a temperature, when earth was formed, can you imagine water can be present in its liquid form? H2O in the liquid form? No, you cannot imagine, because everyone knows that the boiling point of water is 100 degrees Celsius. So water will be evaporated. So continuously evaporated. The clouds formed, but the rain was not able to reach the surface of the earth. But because before it reaches the earth, it will be evaporated. But gradually, the earth started cooling, and it cooled, and the first drop of water reached the earth. Or the first rain reached the surface of the earth. Can you imagine about how much years the rain continued? It was a continuous 40,000 years of rain. 40,000 years of rain. You can imagine about 3 days of continuous rain and the catastrophic flood happening elsewhere in the world. And what will happen about 40,000 years of rain? So that rain has created the ocean, the bigger lakes, and all the water body are the water cycle on earth. So it not only created water bodies, but what happened is that it erased most of the topography or morphology of the earth. Like the impact craters, the depressions, etc. has been erased, the volcanism has been erased, new rocks started forming by erosion, weathering, and redeposition, etc. New rocks were formed. So the 40,000 years rain was created bigger impact on the earth. So that is how that rain occurred, or the first rain or the hydrosphere originated on the earth. And it occurred at 420 crore years before the first rain. So that means that for about 37 crore year, there were no water, liquid water on the surface of the earth. So whether we can expect any life without water? Probably no. Without water, there will not be any life. Okay, so the third sphere is the lithosphere. It is about the rock. So I have told that when, like I have given an example, when a sack of material is kept and you make it a jerk, the heavier materials go inside and the lighter becomes or float on the top. The same is the case with earth. What happened when the earth is formed? The entire earth was in the molten stage, and gradually the heavier materials sink inside the earth. That is how we are saying that the core of the earth, it is made up of nickel and iron. So nickel and iron is in the molten stage in the core. So based on the density of the different materials occupying inside the earth's lithosphere, litho means rock, lithosphere is divided into three: core, mantle, crust, the top. So the crust is made up of lighter material, whereas the deeper part or the middle part, center part of the earth is made up of heavy materials like nickel and iron. So that is how the lithosphere was formed. And later on, the biosphere emerged. And I will say when the first life was originated later. So this is how the earth was formed. So I have mentioned about the origin of the earth and how the three important sphere has occurred. So now if you look into the history of the earth, there are major events. So I'll be mentioning only a few major events. Like if you look into the history of modern history of the world or India or any other country, you will be dividing the history into different parts depending upon who ruled or what are the importance of that one. So similarly, the history of the earth is also divided into different intervals which are not equal, unequal, because some important events happened. So initially, when the earth was formed, I have mentioned two important processes. The one is meteoritic impacts, which we call as heavy bombardment. So what happened is that the meteorites were continuously bombarding the earth. That is the first major geological process occurred on the earth. So in a single event, even if life is there, every life will be collapsed. It undergo extinction. So such a catastrophic phenomena is meteoritic impacts. So there are so many advantages for this meteoritic impacts. I have told the earlier earth was called Gaia, and we are going to now say about an important meteoritic impact. So there is a planet called Theia, which is almost the size of Mars, and this Theia at 450 crore years before hit the Gaia. It collided with the Gaia or the primitive earth, and a good part of earth is taken back and dropped at a place, and that material is the present day moon. So moon was not formed from the initial nebula, rather it is formed by the collision of the early earth called Gaia with a Mars-sized a planet called Theia. So a combination of Theia and Gaia is what we see as moon. So the earth's good portion of earth has been taken as moon. Otherwise earth should have been much bigger in dimension. So that is the major event which happened on the earth during that time. So there are importance for meteoritic impacts. So second importance I can say is that a few meteorites have reached the earth, and the scientists have studied, and they could see some microscopic tubular material. So they believed that these are living creatures or unicellular organisms in a much older meteorite. So believed that the life on earth was not originated on earth, rather it was carried from other bodies to earth. So but those scientists, those who believed in that school of thought, was never ever to thrive in such a scientific development, because scientists have started questioning, okay, life have formed on other planets, but how it have formed in other planets? That is a question if you talk about the origin of the earth. So they were ruled out, that theory was ruled out, which is called theory of panspermia. But in 1990s, early 1990s, NASA scientists or United States Geological Survey, USGS scientists, a combined field work at Antarctica in a hill called Allen Hills, they collected a sample, and in that one also they received a tubular, microscopic tubular things. So you have to wonder, because the then president of United States of America has, I think it was Bush, has informed in their parliament or in the Senate about the discovery of life in a meteorite. Now you can understand how much importance is a meteoritic impact. But again, they were not able to, unequivocally, they were not able to mention about the origin of life in that sample. So the next importance, if I will say about the meteoritic impacts, is that about 65 million years before, that is something about 6.5 crore years before, the earth was ruled by dinosaurs. We all have a belief that dinosaurs are gigantic creatures, but yes, of course, they are gigantic, but they are simple small creatures, cute creatures. So what the impression about dinosaurs we have is because of what is the movie called Jurassic Park. But the things are different. For example, we do not know how lovely they were. We do not know what is the color of the skin of dinosaurs. We do not know whether it was having a hair, because the fossil, those were the soft parts, and the soft parts are very difficult to get preserved in rocks. So we do not know about dinosaurs much about. Of course, we got several plentiful of fossils. So the advantage of the dinosaurs is that they were carnivorous, they were herbivorous, they were omnivorous. Some dinosaurs were capable of flying, all are capable of swimming, running very fast, and they ruled the entire earth. So what was the fate? At one point of time, that big creature has left the earth. It has undergone extinction. So now you can imagine about the humans. It is our fate is also the same. Once upon a time, we have to leave the earth. So how the dinosaurs undergone extinction? Here also there were so many school of thoughts or so many hypotheses, but the well accepted theory was it was undergone extinction, dinosaur undergone extinction due to a meteoritic impact. So it was proposed by a scientist called Luis Alvarez and his son Walter Alvarez. Luis Alvarez, he is a familiar person in the field of physics. He's a Nobel laureate in 1962, I think, in elementary physics, subatomic particles, in some research. So after his research, Nobel Prize, during his retirement life, his son was a geologist, Walter Alvarez. He gone with his son for a field work in Italy, and in one layer of rock they could see that there is a high amount of iridium. Iridium is an element which is very similar to platinum, and it is included in the platinum group of elements. So this iridium can be seen on the surface of the earth only by two processes. One, either it has to be bought from outer space, some meteoritic impact, or from the deep inside of the earth, because it is a platinum, it is a heavy metal. When earth formed, it has settled down inside the earth. So this platinum can be, this iridium can be brought to the surface either through a volcanism, or the second aspect is meteoritic impacts. So what happened is that they searched for volcanic rocks, or the rocks which is formed by volcanism, which we call it as igneous rocks. So they looked for igneous rock around, and they were not able to identify any igneous rock. All are sedimentary rocks. So they come to a conclusion that this iridium spike, or the high content of iridium, is because of an external source. And they dated it, and they could find that it exactly coincided at 6.5 crore years. That means the time at which the dinosaurs undergone extinction. So they came to a conclusion that it was a meteoritic impact that have resulted in the extinction of dinosaurs. You can imagine a physicist saying a big problem or a huge history of the earth, which was not revealed by any geologist or biologist. So His paper was accepted and published in the journal Science in 1980. So people started arguing with him. They were saying that if such a huge amount of iridium is there, a meteorite of 10 to 20 kilometer size meteorite should have reached the Earth. If a 10 to 20 kilometer diameter meteorite reaches the Earth, it will be capable of creating a depression or a crater of diameter 100 to 200 kilometer, a minimum of 100 to 200 kilometers. So such a huge depression will not be missed to a common man. If you say it is a meteoric impact, you show us where is the impact crater. So he was questioned in all the deliberations, in all the seminars, conferences where he attended. So I can frankly say that that paper of Luis Alvarez and Walter Alvarez, which appeared in the Science journal, is the most highly debated paper in the last century. But things changed in 1992 when a few other scientists were able to identify an impact crater something about 120 kilometer or 180, I think 180 kilometer diameter in Mexico, a peninsula in Mexico called Yucatan Peninsula, and that crater they named as Chicxulub. So that Chicxulub crater is about 65 million years old, exactly coinciding with the extinction of dinosaurs. So the question now, the crater which formed in Mexico, and the Walter Alvarez and Luis Alvarez identified that iridium in Italy. How can it possible? Yes, it is possible. When an impact happens, the ejecta will be spilled out, and depending upon the velocity, depending upon the trajectory angle, the ejecta will go far away. So this Chicxulub crater in the Mexico, the ejecta has reached all over the globe. Even in India, there are 3 or 4 places where the ejecta from Mexico has been identified. Not only in India, not in this impact, but Earth material might have reached other planets also, because so far humans didn't identify any Earth material on Moon or Mars, but we have on Earth meteorites from Moon, meteorites from Mars. So how it comes? Because even if good impact happens on Mars, its ejecta will get spilled over and some escape its velocity, gravitational field, and travel haphazardly, and sometimes it reaches Earth. There are so many incidences in which we got Martian meteorites. If I can say an example, a place called Shargoti in Bihar in India, and we got several Mars meteorites, and that particular Martian meteorite is called Shargatite. So I have explained a lot about meteoritic impacts from the origin of life on one end to the extinction of animals on the other end, 2 end members, and several other processes in between of meteoritic impact. So that is about meteoritic impacts. So you know how a meteoritic impacts, or how the dinosaurs were fascinated to our humans, not only to geology. You might have seen a movie called Jurassic Park, which appeared in several series, which is an example how good or how impressive the creature dinosaurs are. Or you might have seen a Hollywood movie called Armageddon, where Bruce Willis was acting, where an asteroid is coming towards the Earth and going to have a catastrophe on Earth. So they are making a manned mission to the asteroid. They landed there, they blasted that asteroid and saving the Earth from potential devastation. So these are the things about meteoritic impacts. So the next important geological process I can say is volcanism. So volcanism, I have mentioned, the Earth was so hot, all over the Earth it was bubbling with lava, pouring lava, gas is emitted, the first atmosphere gone, and the second atmosphere was formed. And this second atmosphere was formed only because of the degassing from volcanism. The gases which were trapped inside the earth were degassed to the atmosphere, and a new atmosphere was formed. And that much important is volcanism towards earth. Moreover, the other importance, I can say that everyone is familiar with Siberian volcanism or Deccan volcanism. What is the importance of Deccan Plateau in India? Because in the school also we have studied it, the most fertile soil is the black soil. So black soil comes from lava, basalt. So volcanism can create fertile land, and thus we can improve our agriculture. The third importance I can say about volcanism is the mineral deposits. All the major mineral deposits on the earth is associated with volcanism. I can say you an example. Diamond. Diamond is a mineral which is formed something about 75 to 200 kilometers below the earth's surface. So how it is brought to the surface of the earth? Because the volcanism which originates below the layer of diamond, when it comes its way upward, it takes the diamond and come to the surface and drop it here and there. So that is how we are getting diamonds, otherwise we should not get diamonds. Gold, platinum, silver, copper, nickel, all the things, all the metals, important metals which rules the earth are from volcanism. So these are the importance of volcanism, but rather the beauty of volcanism is different. Of course, it is a devastating phenomena, but it is like a Diwali for the geologists. The different colors of lava which pours or which is ejected in a volcanism is a beautiful eyesight in the night. Hawaii, a place or an island in Pacific Ocean which is under the control of United States of America, they used to have tourist attraction in the evening, make cruises around waters in Hawaii. So to see the waters and motley or the different colors of lava. So tourist attraction will be there, but the thing is that everyone should be careful when you are approaching a volcanism, because it is dead hot. You cannot predict the effusive nature of the volcanism. It can be a silent eruption, it can be a wild eruption, and a single droplet of lava, if it fell in your hand or something else, it is about 700 degrees Celsius. Can you imagine what happens? You can imagine. So you have to take all precautions or get advice from a geologist before reaching or going nearby a volcano. So the best ideal place for you to see volcanism present day is Hawaii or Yellowstone National Park, where you can see a multitude, variety of or manifestation of volcanism, from boiling mud volcano to geyser to hot spring. A lot of things you can see in Yellowstone National Park. The present day volcanism are mainly concentrated along the borders of the bigger plate called Pacific plate tectonism, which I'll be mentioning later, plate tectonism. So Pacific is a big plate. Around the margins of the Pacific plate, there is a lot of volcanoes are there. That's why Japan is there, Hawaii is there, Andes Mountain is there, all these things. So we call it as ring of fire for that area, because it is like a ring, and a lot of volcanoes are concentrated. And in about few minutes before, I have mentioned you that I'll be talking about a recent eruption of Mount Pinatubo in Indonesia. So in that single volcanic eruption, it ejected 2 crore tons of sulfur dioxide. A single volcanism which is capable of ejecting 2 tons of sulfur dioxide, and that sulfur dioxide cannot be detected as a 0.1% in the atmospheric constituent, then you can imagine how much the nitrogen, oxygen or all other things are occupying the Earth's atmosphere. Of course, nitrogen is not the sole reason, is not volcanism, but you can imagine the quantity of such gases present in the atmosphere. You cannot exhaust oxygen. You cannot complete carbon dioxide. Such huge amount it is there around the Earth. So if Pinatubo is capable of 2 crore tons of SO2, then you can imagine about the other bigger volcanism. And that single Pinatubo eruption was capable to drop the global temperature by 0.5 degrees Celsius. Because you see, during volcanism, a lot of smoke also comes. Minute debris will be there, which will remain suspended in the atmosphere, which will not permit the sunlight to reach inside the Earth. So the temperature gradually gets cooled, and that has resulted in 0.5 degrees Celsius drop in the global temperature. And this also you might have seen also fascinated our layman's mind also. You might have seen a movie called Pompeii, a Hollywood movie called Pompeii, which shows a village. Pompeii is a village in Italy, and it was related with an volcanic eruption from Mount Vesuvius. In a single night, the ash, the debris from the Mount Vesuvius have engulfed a village called Pompeii, and several people died because of this ash fall. You can still see the remains, the mummified bodies in the Pompeii, and that has been now considered as a UNESCO heritage site. So such is the importance of volcanism. Such is the catastrophic nature of volcanism. So related with that Pompeii village, a movie came as Pompeii. Then other famous movie was there called Dante's Peak, which is a box office hit. So that why I'm mentioning about the movies is that these are the phenomena which are capable of catching the mind of a common layman. And next important phenomena which I can say is that when did the life started? When did the life started? So if you want to know about when did the life started, we should understand the rock types or the age of the rock on the earth. Because there are 3 types of rocks: igneous rock formed by volcanism from lava or magma. The second is metamorphic rock. Metamorphic rock is formed by the change in pressure and temperature conditions, but in the solid stage. In igneous rock, it can be in the liquid stage. Of course, in the liquid stage means pressure and temperature are high, but here pressure and temperature are there, but in the solid state. Third is sedimentary rock, which is formed by the erosion of pre-existing rock, get it consolidated and form layers of rocks. So the other first two which I have mentioned, igneous and metamorphic, are hard rock, high pressure and temperature. So these 2 rocks are not capable of hosting fossils, because even if fossil is there during the high temperature pressure condition, that will also forms part of the rock. Whereas in the sedimentary rock, fossils can be very much well preserved. So geologists are wondering or pondering where we can identify the oldest rock. So far, the oldest mineral, of course everyone knows that it is an ingredient of rock, is we obtained from a place called Jack Hill in Australia, so which is about 439 crore years. I have told 456 to 57 is the age of the earth, and we got the oldest zircons of 439. So we don't have the rest of the history. So it is just a mineral called zircon. So then we got the oldest rock. It is in Canada, which is called Augusta Gneiss, in a craton called Slave Craton, and the rock is something about 403 crore years. But unfortunately, it is a metamorphic rock. So we don't have that much evidence in the first rock about life. But we got evidence from 3.8, a sedimentary rock from Greenland, Iswa group, and unfortunately, as this is too old sedimentary rock, that also got converted into metamorphic rock. Initially it was a sedimentary rock, but again it has undergone metamorphism and become a metamorphic rock. So we don't have any evidence. The first evidence of life, we got it at 3.5 giga-annum, or 3.5 billion years, or 350 crore years. And those are called stromatolites. So stromatolites are still seen in different parts of the world. So you can understand they were living in water. So it is very similar to, I can say, if you correlate the stromatolites, you can correlate with corals. It is very similar to corals. So initially, when I was talking about when the first rain occurred, you can imagine if in a place, if there is no rainfall about 2 to 3 years, and then rain occurs, you can see how much dust particles it will carry, how much contaminated it is. So this water, when it was coming down, when the first rain, it was taking a lot of impurities from the atmosphere, which was ejected by volcanism, etc. So the initial ocean, when it was formed, it was red hot in color. So it is red or brown in color, full of iron, etc. Because during that time we are not having oxygen, free oxygen in the atmosphere to oxidize the iron. So these stromatolites were living in such brownish, dark, red color water. So no oxygen was there, so it may be breathing some other things which I'll be mentioning later. So we got the first evidence at 3.5. So before that we don't have any evidence. So again, the 3.5 is marked by another important phenomena on Earth, which we call it as plate tectonism. The surface of the Earth is made up of different plates, small and big. India is a plate, Pacific is a plate, and small Honshu is a plate, small plate. So similarly, so many plates are there. These plates are in continuous movement. Continuous movement, how it moves? Because beneath the lithosphere crust, there is a mantle. So this mantle has mantle-driven currents called convection currents, which makes the plates move here and there. So this plate tectonism has a huge role because the volcanisms are concentrated in the plate margin, earthquakes are concentrated in the plate margin, and moreover, the plates can collide each other, give away or move away from each other. When it collides, it forms mountains. Himalaya is formed by the collision of Indian plate with the Eurasian plate. So that is the next important event, plate tectonism. So plate tectonism has a huge role because if I can say an example, Mars, once upon a time there was plate tectonism on Mars. But what happened? At one point of time, and Mars was having water. Mars was having ocean. If you look what is the shape of the Mars, its topography, you can see that one part is water and one part is land. So there were only two plates in Mars, so it were moving, and somehow one got undergone or subducted beneath another plate. During when it took all the water from the Mars to deep inside the Mars. So there is no water, so there is no movement. You see, you need lubrication for moving. Water is the most important lubricants for moving. So there is no water on the surface of the Mars now. So there is no plate tectonism. So what happens if there is no plate tectonism? If there is an earthquake on Mars, you cannot call it as an earthquake on Mars. You can call it as a Marsquake. If a Mars quake occur, the entire Mars will shiver. If a an earthquake occur, a moonquake, I can say moonquake, a moonquake occurs, the entire moon will shiver. Because there is no plate boundaries through which the energy can dissipate it. So we are safe on Earth when an earthquake occurs in USA, in San Andreas Fault. The person who is sitting in India never feel it, because in between there are so many plates and the energy will get dissipated through that one. So that is the importance of plate tectonism. We are safe. We are very much safe. Only a certain part is affected during this earthquakes. And next saying about the most important thing is the great oxygenation event. That is the time in which the oxygen was first liberated to the atmosphere of the earth. I have told there was no oxygen on the surface of the earth or in the atmosphere of the earth when earth was formed. Oxygen was there, free oxygen was not there. So the first oxygen was liberated to earth at 250 crore years before, and that is a time in which cyanobacteria, a unicellular organism, started photosynthesis, converted the other gases in the atmosphere and started pumping oxygen into the atmosphere. So till that time we do not know what they were using, the organisms were using for breathing. Actually, the scientists say that they were using methane. So the process of breathing methane is called methanogenesis. So now we have oxygen and we are living or adjusted to with oxygen. Can you imagine if oxygen is all of a sudden removed by some other gas, whether we will thrive? No, most of us will die. Similarly, scientists are also not aware what happened at 250 crore years before when oxygen was first liberated to the atmosphere. Whether it was the major extinction in which all the organisms were killed or vanished or undergone extinction, or whether it was able to switch over from anaerobic to aerobic respiration, that is a big question. Unfortunately, we are not able to say much about the history because during that time, even if organisms were there, they were unicellular organisms, and getting evidences for unicellular organisms is much difficult. So again, next time at about 55 crore years, a second burst of great oxygenation event happened. A huge amount of oxygen was liberated, and that is almost equivalent to the present day oxygen content on Earth. So that has marked the beginning of the life of multicellular organisms. Till that time, or till before the second pulse of great oxygenation event, we are having unicellular organisms. But when the second time when oxygen was liberated, there was a huge explosion of organisms. A multitude of multicellular organisms evolved, which we call it as the Great Cambrian Explosion. Cambrian is a geological time period. So from that one, the history started. The earth have seen different varieties of life. So these are the major events which I would like to mention when we talk about the history of the earth. But what is the future of the earth? What happens? At one point of time, we all have to die. Not in a normal way, but in a catastrophic way. If dinosaurs can undergo an extinction by a meteoritic impact, why can't humans? If you take the life of the humans, and if you convert the Earth's history into a 24-hour clock, I can say that human came to the Earth at night 11 o'clock, 59 minutes and 59 seconds. We were not on the Earth even for a 1 second of a 24-hour clock on Earth. But you can imagine about the changes, positive or negative changes the humans have brought on the surface of the earth. So we were here for only for about few lakhs of years in the 457 crore years history of the earth. So the end of the life is not far, it is very near. The scientists believe that if you convert the life of the sun into a 12-hour clock, now it is 4:30 in the morning. If you convert the life of the sun into 12 hour, now we are living at morning 4:30. At 5 o'clock, the entire life on the earth will get vanished. Not because of any catastrophic phenomena, but as usual, because the earth was, when it formed, it was a little further from the present position. Now it was a little nearby. Moreover, the sun's luminosity is increasing day by day. The initial sun was not that much bright as what we are seeing today. It is said that how sun's luminosity, it is by nuclear fusion. Hydrogen and hydrogen join and form energy. So if you calculate the content of the hydrogen present in that sun, it can live only up to 1200 crore years. 1200 crore, of which something about 456 or 460 crore year is over. That is, I have told, if you convert the 1200 into 12-hour clock, we are at 4:30. So sun's luminosity increases, and then the environment or the climate of the earth will be hostile for the life organisms at 500 crore years. So the life will be vanished. At 8 o'clock in the morning or 800 crore years, the water, the entire water in the earth will get evaporated, and we will be devoid of water. And at 12 o'clock in the noon, earth will be captured by sun. Before capturing earth, Mercury and Venus will be engulfed already by sun. And what happens? Earth will and the sun all will collapse. The sun will become a red giant or a white dwarf, not a black hole, white dwarf. So again, what happens? The same thing else will form a new nebula. New stars will be formed, and that new stars will create new organisms, and that will be the life. It goes on and on, but we are here for a short life. Thank you.